This is the last part of section 6.4. So, how can we solve exponential equations of base e or base 10? Well, we can isolate the exponential part and then change the exponent into a logarithm. And so then on the calculator, you either use the log key if it's base 10 or the ln key if it's base e to evaluate the variable. So for example, e to the x equals 7 we can change into using the log ln of 7 equals x. And then we can plug that into our calculators and get a number. I'm not going to do that. Okay. By the same regards, we have to isolate the exponential part on part B. So first we have to divide by 2. So we get e to the 3x equals 3. And then we just use the rules. So natural log of 3 equals 3x. So x equals the natural log of 3 over 3, which you can then plug into your calculator to get an answer. Part C, we have natural log of 9 equals 5x minus 1. So we add 1 to both sides, so we get 1 plus the natural log of 9 equals 5x, and then divide by 5. So 1 plus the natural log of 9 divided by 5 is x. And you can put that in your calculator. Okay, part D, we have a little bit of work to do. So first we have to subtract 1. So 4 times 10 to the 2x equals 20. Then divide by 4, so 10 to the 2x equals 5. And now we can use log base 10, so log base 10 of 5 equals 2x, or x is log base 10 of 5 divided by 2. On E, we have 3e to the 2x plus 1 equals, adding 2 to both sides, we have 12. Divide by 3 now, so e to the 2x plus 1 equals 4, which means that the natural log of 4 equals 2x plus 1. So negative 1 plus the natural log of 4 equals 2x. Subtracting 1 from both sides in that step. And then divide by 2. So the negative 1 plus the natural log of 4 divide by 2 equals x. Okay, moving on to the last page. So, use a calculator to evaluate the expression. If we do that, we get approximately 2.303 when rounded to 3 decimal places. Unrounded is still an approximation, is going to be 2.302585093. Okay. Get rid of that accidental mark I made down there. Okay. So, a word problem. The loudness L of x measured in decibels of a sound of intensity x measured in watts per square meter, defined as Lx equals 10 log base 10 of x over I sub 0, where I sub 0 is 10 to the minus 12 watts per square meter, is the least intense sound that a human can detect. A particular Boeing 747 produces noise at a loudness level of 113 decibels. Find the intensity level, rounded to the nearest hundredth, in watt per square meter for this noise. So we know that L of x equals 10 times log x over the I sub 0, which is 10 to the minus 12. So 113 equals 10 log 10 to the minus 12 in the denominator is really 10 to the 12th power in the numerator. And we're going to divide both sides by 10 here. So that gives us 11.3 equals log of 10 to the 12 times x. So let's change that into exponential notation. So we have log base 10, so we have 10 to the 11.3 equals 10 to the 12 times x. Then we have to divide both sides by 10 to the 12th, so we get 10 to the 11.3 over 10 to the 12th equals x. And if you put that in the calculator, you will get 0.20 watts per square meter is x. So that's the end of the 6.4 lecture.